In this video, I will show you how to use a given zero to write a polynomial as a product of linear factors, and we're working with complex zeros in this case. It says for the polynomial below, 3 is a zero. So they gave it to us just like that. So I don't have to graph it. I don't have to use a rational zeros theorem. They gave us a starting point. So guess what we're going to do? We're going to use that to divide our third degree polynomial. Look, the degree is 3. What does that tell us? F of x has 3 zeros, which means we can write 3 linear factors. Once we find 3 zeros, let's use those 3 zeros to write 3 factors, okay? I need to find 3 answers. They gave us one to start with. So let me go ahead and put that 3 in the box. Write my coefficients, 1, -7, 65, and -159, and I'm going to do my synthetic division. At the end of the synthetic division, I really want to see a remainder of 0. Because they did say 3 is a 0, we better get a remainder of 0. Bring down the 1. 3 times 1 is 3. Add and get -4. 3 times -4 is -12. 65 plus -12 is 53. And look at that, 3 times 59 is 159, and the remainder did come out to be 0, yay. So what should we do now? We just confirmed that 3 is a 0. Now what we need to do is set this quotient equal to 0 and solve for 2 more zeros. So this quotient is x squared minus 4x plus 53. Set it equal to 0. And let's solve this. In class, we use quadratic formula. I do want to show you how to do this using completing the square method this time. So to do that, I will go ahead and move that 53 to the other side temporarily. And let's think about what we are adding to both sides. To complete the square, I need to add half of the middle term squared. Half of -4 is 2. Well, to be exact, -2. But if you square -2, you get +4. So you must add 4 to both sides. Okay? And if you factor the left-hand side, you will get x minus 2 squared. And on the right side, we're going to get something interesting. We're going to get -49. Okay? I am now going to take square root of both sides. If I do that, it comes out to be x minus 2 on the left side. And if you see this one, by the way, because we took even root, we better put plus or minus sign. What is square root of 49? Square root of 49 is 7i. Okay, that's 7i. Last thing I need to do is I need to add 2 to both sides. And by adding, I'm just going to move this right after that equal sign. So x equals, oopsies, I'm going to say x equals +2 plus or minus 7i. So I found two more imaginary zeros. So these are the solutions. These are the zeros of this function. So let me write all the zeros in a single line so that I can look at them to write write in factor form. Okay. So let me go ahead and make this a little bit smaller. And on the side, so what are the zeros of f? Zeros of f are the one they gave us first. They gave us, one of them was 3. The second one that we found was 2 plus 7i. The third one that we found was 2 minus 7i. So these are the 3 zeros of f, okay? Now we need to write factored form. So f of x equals, it's always x minus 0. So the first one is x minus 3. What's the second one going to be? Now look, the second one is a binomial. So I have to do x minus exactly what this is. Okay, I'm literally going to duplicate this, okay? Duplicate it down here. So that is factor number 2. And I need to write another factor. I think I'm going to need a little more room. So I have to do x minus, it's always x minus, and the third 0 is this green parenthesis, so you have to do x minus that. And you close that outside parenthesis. And that is how you write a function in product of linear factors form, okay? So you have to find zeros using what you need, doing what you need, like quadratic formula or completing the square, or sometimes simple factoring may work too. But as the problems get a little more complicated, you may get irrational zeros, you may get like imaginary non-real zeros. So I do want you to get more comfortable with either the completing the square method or the quadratic formula method. But this is, I think the topic name is using a given zero to write a polynomial as a product of linear factors, complex zeros. But I feel like this one is difficult, but I only showed you one example of it. So if you need me to show you more, just reach out to me, okay? I will come back and go over, I think we did go over linear factors theorem in class, but I'll come back and go over page 6 in another video soon.